So yeah, it is 2/2/23. Tomorrow is 2/3/23. 2/2/2/3. What a cool date. And yeah, this is basically just yesterday's stuff, adding and subtracting radicals. So add, subtract radicals, continued. And instead of radicals, like we could put square roots. So here's our first example. I just resumed my recording, so no one say any dirty words for God's sake. So this will be really familiar. I'm going to say the same thing I said yesterday, and that is that if you can't simplify radicals, then that's just going to manifest itself here in this assignment again. So let go whatever conversation you're having now and just resume it later if you'd like, but we got to move on now. So we got three radicals here that we have to add together, right? And I think all of yesterday's, am I correct in that there are only two? So in today's assignment, you're going to see three. I had the option to make it, I think, 4 or 5, and I think I just settled on like 3. So what you'll find in some of today's problems is all the radicals will eventually mate together and become one. And in some of the problems, not all of them will be able to go together. So that's why I have 3 examples so you can see a little bit of everything. So in this problem up here, we got to break them all down. So yet again, more and more practice with this skill. So I can ignore the -3. Right in front. I can just focus on this. How would I tree down a root 8? A 4 and a 2, right? And then I hop that next step. Thank you, Sage. And I call it a 2√2. And then when I multiply by the -3, what do I get? I get, so I, -6√2 makes this first one now done, right? Bryce, did you have a question, bud? Okay. Let me know when we get there, huh? Yeah. All right, so for this second radical, again, notice I'm ignoring the 4. I'm only going to ignore it, but don't, like yesterday, don't forget that it's there at the end, right, Chance? So it's there. We're just going to kind of put it on the back burner for now. Seriously. So if I take the square root of 128 and I break it down, what 2 numbers do I want to use? You've seen this one before. Nope. It's a really big number times a really little number. Yeah. And so the more you practice this, the more you just start to see numbers and remember, hey, I've seen you before. 128 is a weird one, but it does go 64 times 2. And 64 times 2 is awesome because the square root of 64 is 8. And Kale asked the question yesterday, and it's a really smart question. Like, how do I know when I'm done? Like, how do I know when I found the best root possible? And the answer is always look at your trash root. And if the trash root is not breakable anymore, then you know you've done your best. If your trash root is like an 8, then you go, I didn't go far enough, right? I didn't go big enough. So just always look at the trash root. And if it's like a 2 or a 3 or a 5 or a 10 or something garbagey, then you know you've done well, right? So let's take that 4 that we almost forgot about and multiply it by 8, and we're going to get a plus 32 roots of 2. Okay, and then I'll switch colors one more time. Let's break down this root 48. How do you deal with a 48? 16. Yeah, and 16 and 3 again is just the perfect response. There's so many garbage numbers that, listen, 48 is very makeable. There's a ton of ways to multiply to make it, but the only one that I really give a rip about is the 16 times 3, because 16 is a beautifully rootable number, and the garbage root, the 3, you know, is dead, right? So 4 and 12 is one of those like trap ones where 4 is nice, but then you look at 12 and go, I didn't go right. And so all this practice makes us start to see numbers and just remember what to do. 16 times 3 is 48. Oh, yeah. So that's why we're taking notes, right? If what's about to happen weren't about to happen, we wouldn't be taking notes. I would have just handed out the worksheet. So yeah, this blue thing becomes 4 roots of 3, which when I multiply by this negative sign in front, yeah. So really all I'm going to do is just stick a -4 root 3 at the end. So let's pause real quick and just make sure as you frantically try to get this into your notebook, is everyone okay with what we've done so far? It's really just yesterday on steroids a little bit, right? A little bit of extra juice in there. So what I see, and Kale had the exact correct response, is to say like, whoa, hold on. We got a problem. And so I just want you to be prepared for this fact that sometimes you do your level best, but all the parts and pieces just don't go together. listen, in algebra, sometimes we just accept, we take what we get, as they say. So if we had like 3x plus 4x minus 5y, you don't force the issue, you put things together. So you get 3x plus 4x makes 7x, and then you just copy down the minus 5y. It is what it is. So at the end of this, we will get 26 roots of 2 minus 4 roots of 3, and we accept it and move on. Yes. Bingo. Yeah. So I just wanted you to be prepared for that. And we may not need 3 examples. I'll definitely do one more, but so just be accepting of the fact that on at least half of these, I think, maybe more, I don't know, you're going to get to the end and go, oh, I can only maybe put a couple of them together, but I've got the odd man out, so to speak, over there. Yeah. No, it's on paper. Delta does a really poor job with these longer problems.
You changed the date on yesterday?
Yeah.
Okay.
Yeah. Did I not do it yet? My bad. Let me remember when I'm done here. Don't let me forget. And I'll change it. So let's do at least one more example. And if you feel after this example, like, hey, I could use one more, just let me know. So let's do -3 roots of 32 plus 4 roots of 18 minus 5 roots of 50. So at this point, they should all just look like blah, 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 right? We have no idea who their true identities are. So that's why we go through this process. We break them down, and what we get is what we get. So one by one, and I'm just going to use my colors again. Let's start over here with Mr. Red. How do you break down a root of 32? Yeah. And again, that's just practice and training and memorization. You do something enough and you just start to know. 32 can be made other ways. The only one we care about is 16 times 2. It's the best we can do, literally the best we can do. So yes, it becomes 4 roots of 2, which when multiplied, very good, makes -12 roots of 2. All right, so the first one we can say, you're done. Let's head on to the second guy. I'll switch to blue. How do you break a root 18? Definitely 9 and 2. And that becomes 3 root 2, which in the end becomes +12 root 2. I'm going to switch back to my white pen here, sorry. So +12 roots of 2. And then the last one I have is this one, and I heard it coming from the back already. Definitely want to use 25 times 2. If you're still thinking 5 and 10, then I'm just not doing my job, right? I'm just not doing my job well enough if that even crosses your mind. 5 and 10 are trash. 25 and 2 are fantastic. And then that makes 5 roots of 2, which when conjoined makes, right? And so this is, I wanted you to see that this can also happen today, that all your roots can come together and say, hey, let's all reveal our same color or whatever you want to say. And then you look and say, okay, -12 roots of 2, more roots of 2, less roots of 2. Hey, they can all go together. So you just got to do some second grade math now. What is -12 plus 12? 0. So your answer is just -25 roots of 2. You guys feel like you got this?
Yeah.
All right. So I'll change the Delta Math date on assignment 12. No, assignment 6 to be tonight, or no, I'll do Sunday night at midnight. That's because tonight doesn't make sense. And then this one you'll have done by Monday also. The paper. Good deal? I know.